In this video, we will see about the concept of passive reinforcement learning and its various approaches. Reinforcement learning is a machine learning technique whereas an agent learns through trial and error in an environment. Unlike supervised learning, where the agent receives labeled data, reinforcement learning provides rewards or penalties based on the agent's action. Passive reinforcement learning focuses on learning about the environment without actively selecting actions. What is reinforcement learning? Think of reinforcement learning like training a dog. The dog acts as an agent here, interacts with the environment, which is the world, by taking actions like fetching the ball, sitting, standing, running, etc. The trainer is considered as an environment, provides rewards like treats or praises or penalties like scolding based on the dog's action. The dog learns through trial and error to perform that leads to rewards. We have two types of reinforcement learning. One is active reinforcement learning and another one is passive reinforcement learning. Passive reinforcement learning is like watching someone else playing a video game and learning the rules and strategies by observing their actions. Whereas active reinforcement learning is like playing the video game yourself and learning through the trial and error. This is the difference between active and passive reinforcement learning. In passive reinforcement learning, there are three different approaches in how they learn about the environment without actively selecting actions. We will explore approaches in detail in following slides. We have three main approaches like direct utility estimation, adaptive dynamic programming, and temporal difference learning. What is direct utility estimation? Imagine you are in a maze. Direct utility estimation would involve remembering the total reward you received from each point in the maze on average. This can slow, especially for large environment. Next is adaptive dynamic programming. Adaptive dynamic programming is a model-based approach. The core idea of ADP is to learn the model of the environment to overcome the limitation of passive reinforcement learning. This model consists of two parts: transition probabilities. This helps the agent understand how likely it is to move from one state to another state based on the action taken. Reward function. This captures the immediate reward associated with taking an action in specific state. By learning this ADP can estimate the expected future rewards for different action in a given state, allowing it to evaluate the effectiveness of a fixed policy without actively exploring the environment. Temporal difference TD learning is another powerful approach for passive reinforcement learning. While ADP focuses on building a complete model of environment, temporal difference learning takes a different approach. Here is how temporal difference learning tackles passive reinforcement learning. The key concept in TD learning is bootstrapping. Instead of building a complete model, TD learning directly updates the value of a state based on the current estimated value of the state, that is P of S, the observed reward R of S, A received for taking a action A in a state S, the estimated value V of S dash of next state S dash reached after taking the action. This approach allows TD learning to learn and improve its estimates even with limited information from the passive observation. Next is benefits of TD learning in passive reinforcement learning. Here highlights the advantage of using TD learning in passive reinforcement learning. First one is less information needed. Unlike ADP, TD learning doesn't need the full environment model, making it more flexible. And next is simpler and efficient. It can be computationally faster, especially in large environment, whereas in ADP it is slow in larger environment. Online learning, it can continuously learn and adapt as it absorbs new data. Both ADP and TD learning offers powerful tool for passive reinforcement learning. While ADP builds a complete model, TD learning leverage bootstrapping for efficient learning. The choice between them on factors like the complexity of the environment and the available information.